In this video I'm going to go through the solutions for the first algebra test. So starting off, question 1, we're given an equation that we need to solve. We have x equals the square root of x plus 6. So the first thing that kind of sticks out is the square root sign. So in order to get rid of that, we're going to square both sides. So we know if we have the square root of anything to be squared, so for example the square root of y squared just leaves us with y. So therefore, the square root of x plus 6 squared will leave us with just x plus 6. When we move all of our terms onto the left side, we see that we just end up with a quadratic equation. To solve this equation, we need to factorize first, and then we solve to find two values for x. So we put in the two factors of x squared, so x and x. Now we need to put in two factors for minus 6 that are going to add or subtract to give us minus 1. So sometimes it's just trial and error, maybe put in ones, see if you get the right result. This one isn't too tricky. We know that minus 3 multiplied by 2 gives us minus 6, and minus 3 plus 2 gives us minus 1, which is the coefficient of the term in the middle. So we know those values will work. And then just to double check, multiply the inside 2, we get minus 3x. Multiply the outside 2, 2x. Minus 3 plus 2 gives us our minus x, which again is our term in the middle. So we know that we've factorized correctly. So now that we have the two factors, we need to let each factor be equal to 0. So x minus 3 equals 0, x plus 2 equals 0, and solve to find two values for x. So we get x equals minus 3 and plus 3. And x equals minus 2. Question 2 was to solve the simultaneous equations. So we're given three different equations. We have to find the three missing variables. So we have to find x, y, and z. So what we do is we take the first two equations, we use them to make another one. We'll call it A. Then we take the second two equations, we use them to make a new equation. We'll call that equation B. So taking our first two. So the first thing we have to do is to cancel one of the variables to make a new equation with just the two that remain. So I'm going to cancel the x variable. So to do that, I'm going to multiply the top line by minus 1. The bottom equation stays the same. So now I have minus 2x plus 2x just gives us 0. Minus 8y minus 3y gives me minus 11y. We get 5z is equal to 3. So we now have a new equation with just two variables, which is what we want. We call that equation A. So now we're taking the second equation and the third equation and doing the same thing. Now because I cancelled x with the first two equations, I have to do the same thing here. I have to cancel x again. So again, I'm just going to multiply the top line by minus 1. I could do it to the second equation. It wouldn't make any difference. I'd still get the same result. And we add the two lines together. So minus 2x plus 2x, we get 0. 3y plus y, we get 4y. Minus 2z plus z, we get minus z. 5 minus 2, we get 3. So now we have our second new equation with two variables. And both equations have y and z, which is exactly what we want. Now really we're just doing the same thing again. We take these two equations, so minus 11y plus 5z is equal to 3. 4y minus z is equal to 3. And we want to find one of the variables first, so we need to cancel the other one. So for this part, I'm going to multiply the bottom line by 5 because I want to cancel the z's. Top line staying the same. Bottom line, I'm going to have 20y minus 5z is equal to 15. Plus 5z minus 5z, I just get 0, so that's what I'm looking for. 20y minus 11y, I'm just left with 9y. So 9y is equal to 18, so therefore y is equal to 2. Now that I found that y is equal to 2, I use this to find z. I take either one of my equations, a or b, and I substitute in 2 for y. So minus 11 multiplied by 2 plus 5z is equal to 3. Minus 22 plus 5z is equal to 3. 5z is equal to 25 when we bring the 22 over. So z is equal to 5. So now we have found 2 of the missing variables. We need to go back up to the start. We need to take any of the 3 equations and substitute in y and z in order to find x. So I'll just take the first one. We have 2x plus 8y minus 3z is equal to minus 1. Again, it doesn't matter which one I take. So 2x plus 8, so I have 2 for y, and I have 5 for z, is equal to minus 1. 2x plus 16 minus 15 is equal to minus 1. 2x plus 1 is equal to minus 1. 2x is equal to minus 2, so x is equal to minus 2. So question 3, we're asked to factorize. So we have x squared plus 7x minus 30. So to factorize this one, I'm just going to use the array model. I can just use the brackets, but just to show a different method. So I put in my first term, so x squared, and my last term is minus 30. Now on the top and the side of the box, I want to fill in the factors of what is inside the box. So x squared, the factors are x, and minus 30. So again, I have to think about the factors of minus 30 that are going to add or subtract to give me plus 7. So 2 and 15, they won't work. 3 and 10, that will. So I'm going to use plus 10 and minus 3. So plus 10 multiplied by x gives me 10x. X multiplied by minus 3 gives me minus 3x. So the two that I need to check are the middle two here, these diagonals. So 10x minus 3x does give us 7x, so I know I've factorized correctly. So my factors are going to be x plus 10 and x minus 3. So if you prefer to just use the brackets, again, as we saw in one of the previous questions, we put in the factors of x squared, we have x and x. We think of the factors of minus 30, so add or subtract to give us 7x, so we have plus 10 minus 3. Check the inside 2, we get 10x. Check the outside 2, minus 3x, we get our 7x, and we know we're correct. So we're not asked to solve for x, we're just asked to factorize, so we're done for that part. So the next expression we're asked to factorize is 9x squared minus 16y squared. So we recognize this as an diffiult idir gall carnog, or the difference between two squares, because we have 9x squared minus 16y squared. So again, we start off by just opening up our brackets. The first thing that goes in are the factors of 9x squared, and it's the perfect square. So square root of 9 is 3, the square root of x squared is x, so we have 3x. Then we have the square root of 16 is 4, square root of y squared is y, so we have 4y, and 1 is moda and 1 is lambda. So very straightforward once you see the pattern and once you recognize that it is the difference between two squares. Part 3 then of question 3 asks us to use factors to simplify the following. So we have 2x squared plus 4x over 2x squared plus x minus 6. So the first thing that we have to do is factorize above and below. So factorizing 2x squared plus 4x, we're taking out what's common. So 2x is common to both terms. 2x into 2x squared, I'm left with x. 2x into 4x, I'm left with just 2. So we have 2x by x plus 2. That's all over. So again, I have a quadratic expression. I need to take the factors of 2x squared to go in first, so 2x and x. At the same time, just over here, I'm going to do it as well with the box, just so we have both methods. So with the box, fill in my first term and my last term. Factors of the first term on the top and the side. factors of minus 3. So I have to think, sorry, the factors of minus 6. I have to think about what factors of minus 6 are going to work so that when we check the inside 2 and the outside 2, or when we check the 2 empty boxes inside the square, we will get plus x. So for example, I could try minus 6 and 1 because they multiply to give me minus 6. Then I'm going to fill in the boxes. I get 2x by 1 gives me 2x. X by minus 6 gives me minus 6x. But if I check the diagonal boxes, minus 6x plus 2x is going to give me minus 4x. That is not the term in the middle. So I have to try other factors. So as I've said, sometimes it's just trial and error with them. Okay, some other factors of minus 6 that we can try is minus 3 plus 2. So plus 2 multiplied by 2x gives me 4x. Minus 3 by x gives me minus 3x. If I check the diagonal boxes, 4x minus 3x does give me x, which is the term in the middle. So the factors that I've chosen do work. So we can fill them in. So we have 2x minus 3 as one factor and x plus 2 as another. So as I said, you don't need to use that array model. If you prefer to just use the brackets, that's fine. Again, once you do that, you've got to just check, multiply the inside 2, multiply the outside 2, and do the check to make sure that you're right. So now we've factorized above and below, but we need to simplify. So what we notice is that x plus 2 is a common factor above and below the line. So therefore, to simplify, our answer is going to be 2x over 2x minus 3. So part 4, we're asked to divide x cubed plus 5x squared minus 29x minus 105 by x plus 3. So the first method we're going to go through is long division. So if we look at the pattern of what we're doing, it can help us to remember kind of the process. So the pattern is we divide x into x cubed to get the value that goes up here, which is x squared. And then we multiply x squared by everything here. So we multiply x squared by x plus 3 in order to get what's going to go here. So we're going to use that same kind of pattern to do the whole question. So x into x cubed, we get x squared by x plus 3 gives us x cubed plus 3x squared. Now we subtract the two lines, so it's x cubed minus x cubed, 5x squared minus 3x squared, and we get 2x squared. And we bring down our next term. Now we repeat the pattern again. X divided into 2x squared, that's going to give us plus 2x. And we multiply 2x by x plus 3. So 2x by x gives us 2x squared. 2x by 3 gives us plus 6x. And again, we subtract. So 2x squared minus 2x squared gives us 0. Minus 29x minus 6x is going to give us minus 35x. And we bring down our last term. Again, x into minus 35x is minus 35. And we multiply our minus 35 by x plus 3. We get minus 35x. And we get minus 105. So 35x minus 35 is going to be plus 35. So that will leave us with 0, which is what we want. 105 minus 105 is really plus 105. So again, that gives us 0. So we know we've divided it in correctly. So the other method that I'm going to show is the array model. Again, we've talked about it before. We can use it for factorizing. We can use it for long division. So this time, because I have x cubed as the highest power, I'm going to have 3 columns and 2 rows. As before, I put in my first term, so x cubed, and I put in my last term, minus 105. I'm dividing x plus 3, so x and 3 is going at the side. So everything there in black is what I know for sure. Everything else now I'm filling in. So I have to fill in the 3 blanks at the top and the 4 empty boxes inside the grid. So first of all, x divided into x cubed, I get x squared. Now I can multiply x squared by 3 to give me 3x squared, so I can fill in that box. Going over to the other side, 3 divided into minus 105 gives me minus 35. So now I can multiply by minus 35 by x to fill in this blank. Now what we have to do is we have to refer back to what we're given at the start. So we have to refer back to our x cubed plus 5x squared plus 29x minus 105. So inside the grid I have my x cubed, I have my minus 105. I have minus 35x, but I need it to be minus 29x. So that means I need to add on 6x. So now that I filled in that box, I can fill in the term on the top. So 3 divided into 6x gives me 2x. And now I can fill in this blank. 2x by x gives me 2x squared. And I need to just check everything. So again, at the end, I check everything. What I need to have in the box is what I start off with. So my x cubed plus 5x squared minus 29x and minus my 105. So x cubed minus 105, that's fine. X squared, sorry, 3x squared, 2x squared gives me my 5x squared. Minus 35 plus 6 gives me my minus 29x. So we know that our solution is correct. So you can use either method to divide x plus 3 into x cubed plus 5x squared minus 29x minus 105. Question 4, we're asked to simplify 3x minus 2 over 4 plus 3 over 5 minus 2x minus 1 over 10. So the first thing we do is find our common denominator. So a number that 4, 5 and 10 divides into. That's the lowest number that they divide into, which is 20. So in order to change 4 to 20, we've multiplied it by 5, so we have to do the same to the number on the top. So we multiply 5 by 3x minus 2. In order to change 5 to 20, we multiply it by 4, so we have to do the same thing on the top. In order to change 10 to 20, we multiply it by 2, so we have to do the same thing on the top. Just be careful with the minus, it's going to be minus 2 by 2x minus 1. And now we just simplify the top. Everything over 20. So to simplify further, 15x minus 4x gives us 11x. Minus 10 plus 12 plus 2 is going to give us plus 4. And that's over 20. Question 5. We have 1 over u plus 1 over v is equal to 2 over or. And we're asked to find or in terms of u, v and u. So we want to make or the subject. The first thing I'm going to do is deal with the left-hand side. Because I have two fractions, I want to make them into a single fraction. So 1 over u plus 1 over v. A common denominator is uv. I've multiplied u by v, so I have to multiply the top by v. And I have to multiply the top by u. Is equal to 2 over or. So just to simplify, v plus u over uv is equal to 2 over or. So in order to get my or above the line, if I'm dividing by or on the right, I'm going to multiply by or on the left. So I have or multiplied by v plus u. If I'm dividing by uv on the left, I multiply it on the other side, so I get 2 uv. So to get or by itself, I'm multiplying or by v plus u, so I have to divide on the right. So now I have everything in terms of u and v, and or is my subject. We have x minus 4 to be cubed is equal to x cubed plus px squared plus qx minus 64. We have to find p and q. So this is our identities question. So really, I just need to do with the left-hand side first of all. All we need to do with this question really is just take our time. So first of all, multiply two brackets. X by x gives me x squared by minus 4 4x, minus 4 by x minus 4x, minus 4 by minus 4 gives us plus 16. and now I have to multiply all of that by x minus 4. So I'm just simplifying what I have in the first bracket, x squared minus 8x plus 16, and then multiplying all of that by x minus 4. Now to simplify, I only have one x cubed term, so I have x cubed. I have minus 4x squared minus 8x squared, which gives me minus 12x squared. 32 plus 16x, I get 48x, and minus 64. So when I'm dealing with identities, I know that the values, or the coefficients of terms on the left are equal to the coefficients of the terms on the right. So I'm just writing out my x cubed plus px squared plus qx minus 64. So my x cubed terms don't give me any information. They're not related to p or q. If I look at my x squared term, my coefficient is minus 12. So therefore, p is equal to minus 12. If I look at my x term, my coefficient is 48. So therefore, q is equal to 48. So that's our solution.